Hello, my name is Luiza, and I am in Mr. Kwan's Grade 12 Advanced Functions class. I'm here today to help you solve an application question that relates to physics. Before we get started, we are going to read through the question, pick out the key information, and determine the steps we are going to take to solve the problem. Question 12 on page 205 of the Nelson textbook reads, the function s of t equals negative a half gt squared plus v naught t plus s naught can be used to calculate s, the height above a planet's surface in meters, where g is the acceleration due to gravity, t is the time in seconds, v naught is the initial velocity in meters per second, and s naught is the initial height in meters. The acceleration due to gravity on Mars is g equals negative 3.92 meters per second squared. Find to two decimal places how long it takes an object to hit the surface of Mars if the object is dropped from 1,000 meters above the surface. In order to ensure we don't miss any important information, we are going to go through the variables in the equation from left to right to see if the information was given or needs to be found. The first variable is s of t, which is the height above the planet's surface. In this case, it is 0 because once the object hits the ground is when the time stops. The next variable to look at is g, the acceleration due to gravity. This information is given to us as g equals negative 3.92 meters per second squared. However, it is important to note that the value will be positive in the equation since the object is being dropped and going with gravity and not against it. The next variable in the equation is t. In the problem, it explicitly tells us that we need to find the value for t to two decimal places. The next variable in the equation is v naught, which is the initial velocity. In this case, it is not given to us in the question. However, since the object is being dropped, we are holding it at 1,000 meters off the surface without movement, thus giving it an initial velocity of 0 meters per second. The last variable is s naught, which is our initial height. At the end of the question, it states that we are dropping the object from 1,000 meters from the surface, which is its initial position before it is dropped. Although this question does not entail grade 12 concepts for the most part, not all the information was blatantly given in the question. But through grade 12 advanced functions, it is evident that logical thinking has been developed further to gain understanding of unfamiliar applications such as this physics one. In order to find the time it takes for the object to hit the surface of Mars, we need to create a plan to solve this. First, we need to write out all of our variables so we can see the variables outside of the question, like so. I have included a graph of the function that can help us visualize the problem. In this case, the domain is x belongs to the set of reals, where x is larger or equal to 0 and smaller or equal to 22.588. The range is such that y belongs to the set of reals, where y is less than or equal to 1,000, but larger or equal to 0. This makes sense since our x-axis represents the time it takes in seconds for the object to hit the surface, and the y-axis represents the distance from the surface in meters. It also makes sense to only consider the part of the graph in the first quadrant because the values for time and distance cannot at any point be negative. Looking at the important points on the graph in relation to our problem, the maximum has the coordinates of 0, 1,000, which shows us that the object was at 1,000 meters from the surface at 0 seconds. The positive x-intercept has the coordinates of 22.5880, which would tell us that once the object hits the ground, it will have been 22.588 seconds, which you will notice is the answer to our problem. Now let's solve it algebraically. The first step we need to take is subbing in all our known values into the equation. So first, we write out our equation without the variables and then just simply sub in the numbers that we have. The next step will involve isolating and solving for t. First, we subtract the 1,000 from both sides to put it onto the left side. Our next step is to get rid of the middle term because it multiplies by 0, and then we can divide both sides by -1/2. At this stage, we are then ready to divide both sides by 3.92. After doing this, we find that 510.204082 is equal to t squared. Our final step is to square root both sides to ensure that t is by itself. For our final answer, we want to ensure that we round to 2 decimal places. So first, we write out the answer given to us by our calculator, and then we round to 2 decimal places. To apply this problem to real-world usage, a new field of research is gravitational wave research. When they analyze and research gravity, they are interested in the differences on planets and how that could potentially impact humans. This could help them to determine how long it will take for a robot to hit a planet's surface after being ejected from its shuttle. People that study gravity are also super important to people like astronauts because of the high-risk situations they are put in when they go to space. Our famous Canadian astronaut, Chris Hadfield, has even said that most of the time you only really get one try to do most of the critical stuff, and the consequences are life or death. That's all we have for today, and I hope it's been useful and I've given you extra insight on the topic. Thanks for watching!